Hello students, in this video we are going to solve the problems of miscellaneous exercise on chapter 13, which is limits and derivatives. Limits and derivatives. This is chapter 13 of class 11. Class 11 NCERT Mathematics. NCERT Maths. So the first question is, find the derivative of the following functions from first principles. That means we are not going to use here the standard derivatives. Only we're going to find the derivative of these functions given here from the first principle. So what is the first one? What is the function in the first question? F of x is minus x. This is minus x. So from the first principle, the derivative of this function, that is f dash x, is given by limit h tends to 0 f of x plus h minus f of x divided by h. Now this is equal to limit h tends to 0. Now you see, if f of x is minus x, then what will be f of x plus h? Just replace this x by x plus h, then you will get the corresponding function. So that is minus within bracket x plus h minus f of x is already given, that is minus x. So here minus x divided by h. Now that's going to be equal to limit h tends to 0 minus x minus h minus minus plus x then by h. So here you see minus x plus x cancel. That's why it's equal to limit h tends to 0 minus h by plus h. So if you cancel these two, you're gonna have minus 1. Then we know limit of constant is equal to that constant. That's why it's gonna be minus 1. So therefore the derivative of this function minus x, this derivative of minus x is minus 1. So I hope you have understood this. Now let me show you the next one. That is, so number 2, here the function is f of x is equal to minus x whole to the power minus 1. So from the first principle, f dash x is equal to limit h tends to 0 f of x plus h minus f of x by h. Limit h tends to 0. Here you see, if f of x is minus x whole to the power minus 1, then what will be f of x plus h? Just in order to obtain f of x plus h, replace this x by x plus h. Doing so, what we will get? We will get minus x plus h whole to the power minus 1. And the function f of x is given, that is minus x whole to the power minus 1 divided by h. Now if we simplify the numerators, then what we will get? Minus 1 by x plus h minus 1 by, so it is going to be plus x by h. So let us multiply both the numerator and denominator by x plus h into x plus h into x. We have multiplied both the numerator and denominator. Then if you multiply both the numerator and denominator by this term, then what will happen? In this case, what will happen? These two terms will be cancelled. Then x into minus 1 we will get. Okay. And in this term, second term, here x is going to be cancelled. We will get only x plus h term. I hope you have understood this. So now let me do so. then what will happen? Limit h tends to 0, we will get here minus x plus h by h into x plus h into x. So we have multiplied both the numerator and denominator by x plus h into x. So here you see minus x plus x cancel. Then we have limit h limit h tends to 0 minus h not minus h plus h, I think it tends to 0 h by h into x plus h into x. So here h is cancel, and cancelling these two we will get limit h tends to 0 1 by x plus h into x. So as h tends to 0, that's why this h can be replaced by 0, and if you replace this by 0, then you will get 1 by x plus 0 into x means x square. So this is our result. This is the derivative of this given function minus x whole to the power minus 1. Now let's move on to next. And third one is sine of x plus 1. So our third function is f of x is equal to sine of x plus 1. So from the first principle, f dash x, limit h tends to 0, f of x plus h minus f of x by h. Now it is equal to limit h tends to 0. As you can see, when it is f of x, then it is sine f of x, sine of x plus 1. Then what will be the f of x plus h? Just replace this x by x plus h, and doing so, what we're gonna have? We're gonna have sine x plus h plus 1 minus sine f of x is sine of x plus 1, that is already given, divided by h. Now we are going to use a trigonometric identity here, that is sine c minus sine d. That's equal to 2 cos c plus d by 2 and sine c minus d by 2. So you have to consider this term x plus h plus 1 as c and x plus 1 as d. Now use this relation here, then you will get limit h tends to 0. So what will be the cos c plus d by 2? So here let me write 2 cos c plus d by 2. Here let me calculate here. Let me simplify here. Our c is x plus h plus 1, x plus h plus 1 plus d by 2. D is x plus 1 by 2. So it will be, so here you see x plus x, twice x, 1 plus 1, 2. So twice x plus 2 plus h by 2, and it can be written as x plus 1 plus h by 2. So that's why it will be x plus 1 plus h by 2 into sine c minus d, sine c minus d by 2. So what will be c minus d by 2? C is this one and d is this one. So c minus d by 2. So x plus h plus 1, this is c, minus d, d is x plus 1 here by 2. So if you simplify this, then you can have x plus h plus 1 minus x minus 1 by 2, which is here you see minus 1 plus 1 gone, minus x plus x gone. So you're gonna have only h by 2. So here it is sine h by 2. So this is c minus d by 2, isn't it? So let me clean this. Okay. Now here we have h. Now you see, when we have, let me clean this part also. Suppose when we have limit of product of two functions f of x into g of x, suppose x tends to something that is a, then we can then you see we can write like this. This is equal to, this is simple algebra. X tends to a, f of x limit x tends to a gx. Okay, so applying this, now here you see we have to separate these two parts. This one is one part and the remaining part is another part. So we can write one more thing, these two can be written here h by 2. Okay, in the next step we will write there to the limit h tends to 0 cos x plus 1 plus h by 2 limit sin h by 2 by h by 2 h tends to 0. Now you see, when h tends to 0, h by 2 also tends to 0, because when h is equal to 0 we can write h by 2 is equal to 0. So that's why instead of h tends to 0 we can write here h by 2 tends to 0, because this is a standard form. Okay, standard limit. So we have already got that limit of sin x by x when x tends to 0 is equal to 1. So we are going to use this limit, standard limit, and using that we will get this part is equal to 1. So hope you have understood this. Okay, now we have limit h tends to 0 cos x plus 1 plus h by 2 into 1. Now you see, as h tends to 0, now you can replace this h by 0, and if you do so, then what will happen? Let me clear this part. You will get cos x plus 1 plus 0. That means you can ignore this term, so that's why we got this. So this is the derivative of sine of x plus 1. Now let me show you that. So now number 4, the given function is f of x is equal to cos of x minus pi by 8. So according to the first principle, f dash x, that means the derivative of this function, limit h tends to 0, f of x plus h minus f of x by h. Now as you can see, f of x is cos of x minus pi by 8. Then in order to find the cos of, f of x plus h, just replace this x by x plus h. Okay, so then it will be equal to limit h tends to 0 cos of x plus h plus, not plus, minus pi by 8 minus f of x. F of x is already given, that is cos x minus pi by 8 divided by h. So in this case we are going to use this identity cos c minus cos d, that's equal to minus 2 sine c plus d by 2 sine c minus d by 2. We're going to use this identity here. So then it will be limit h tends to 0. First term is minus 2 sine c plus d by 2. Sine c plus d. Now consider this part as C and this part as D. And what will be C plus D by 2? What will be C plus D by 2? Let us find from here these two terms. So C is x plus h minus pi by 8 plus D is x minus pi by 8 by 2. So here we will get x plus x twice x plus minus pi by 8 minus pi by 8, we can write minus 2 pi by 8 plus h by 2. And after dividing the numerator by the denominator, you will get x plus, sorry, not plus, here it is minus sign, so minus pi by 8 plus h by 2. So here we will write c minus d by 2, that is equal to, this is the result of c minus d by 2 we will use here. So x minus pi by 8 plus h by 2. Then find c plus d by 2. Sorry, c minus d by 2, not c plus d by 2. So now let us calculate c plus d by 2 to put here. Okay. So what will be c minus d by 2? So this sign will be minus. Sorry. This is c, this is d. Okay. This is c and this is d. C minus d by 2. So when you remove this bracket, then this sign minus will be plus. Then minus pi by 8 plus pi by 8 cancel, minus x plus x cancel. Then we have got h by 2. So here it is h by 2. So let me clean this part. Now there should be h as denominator. Now what are we gonna do? Now you see again this minus 2 can be written here as h. We can write this 2 as here h by 2. Okay, not now, in the next step. And then limit minus sign here, h tends to 0, sign x minus pi by 8 plus h by 2. So limit h tends to 0, we can write sin h by 2 by h by 2. This 2 is written here, h by 2. Okay, and we have separated this part. So now as h tends to 0, so we can say h by 2 also tends to 0. And now this is standard limit, which is equal to 1. So that's why our result is minus limit h tends to 0 sin x minus pi by 8 plus h by 2 into 1. Now you see, as h tends to 0, you can replace this h by 0, and doing so you will get then if you replace this h by 0, then this term h by 2 will be 0. That's why we will get minus sin x minus pi by 8. So that is our result. That is the derivative of this function cos of x x minus pi by 8. So here the function is f of x is equal to ax plus b into cx plus d whole square. Again we are going to use u into v rule. Consider the first function as u and this one as b. So derivative of u into v is given by u derivative of v plus v derivative of u. So let us apply this. derivative of the function f dash x is given by the first function ax plus b, derivative of the second function cx plus b whole square. Then second function cx plus b whole square, derivative of the first function, that is ax plus b. Now you see, first assuming this one as x square, we have to find the derivative first. We know derivative of x square is nothing but 2 into x is x to the power minus x to the power 2 minus 1, that's twice x. So ax plus b into 2 cx plus d. But here you see, let me write cx plus d. This is not only x, so this is cx plus d whole square. So that's why it is function of function. Then we have to differentiate this the term within bracket again. So if you differentiate this, now here derivative of cx plus d, find the derivative of this again, then again plus cx plus d whole square. Now derivative of this, you see a is constant, so a derivative of x is 1, a into 1 is a, and b is constant, derivative of b must be 0. So here is the derivative of this part, this term. So now what we can do here, let me write the 2 here, twice ax plus b into cx plus d, then derivative of cx plus d. So what will be the derivative of this term? Now as you can see, c is constant and derivative of x is 1, so we will get c into 1, that is c, and derivative of d is 0. So this is the derivative of this whole thing. Okay, now plus we have got cx plus d whole square into a. So now what we can do here, you can keep the answer like this as well, or you can rearrange this as 2c ax plus b cx plus d, then plus a into cx plus d whole square. Okay, now you see the answers given in the textbook maybe not in this form, maybe in more simplified form. It doesn't mean that this answer is wrong. Okay, this is correct, don't worry about that. Now let's move on to the next question, question number. So here the given function is f of x is equal to ax plus b by cx plus d. Now here you see, you can assume this one as u and this one as v. So here we are going to apply quotient rule, that is derivative of u by v, where u and v both are functions of x. In that case, denominator derivative of the numerator minus numerator derivative of the denominator by denominator square. We're going to use this rule. Okay, and remember that this represents nothing but derivative. So here f dash x will be denominator. So let me write this way first, ax plus b by cx plus d. Then let us use this. According to this, denominator cx plus d, derivative of the numerator ax plus b, minus numerator ax plus b, derivative of the denominator cx plus b, and denominator square divided by denominator square cx plus d whole square. So if you differentiate this, ax plus b, a is constant, derivative of x is 1, and this is b, derivative of b must be 0. So derivative of ax term will be a into 1, that is a. Now we can write cx plus d into a minus, and similarly derivative of cx will be c into 1 c, and derivative of d is 0, so from here we will get only c. So we can write ax plus b into c by cx plus d whole square. Now you can simplify more. So if you multiply this one here and here, then you will get acx plus ad minus again c into ax, acx plus, sorry, it will be minus bc, cx plus d whole square. So now you see in this numerator, acx minus acx gone. So we can write our answer as ad minus bc divided by cx plus d whole square. So this is our answer. So hope you have understood. Now let me show you the next one, question number 6. So here the function is 1 plus 1 by x by 1 minus x. So 1 minus 1 by x. So here you can you see, before differentiating you can simplify here. If you multiply both the numerator and denominator by x, then what will happen? Then it will be x plus 1 and it turn out to be x minus 1. So now you can apply the quotient rule now. Considering this one as u and this one as v, you can apply u by v, this quotient rule, that is v derivative of u minus u derivative of v by v square. Let us apply this. So now derivative of f of x, that is f dash x, is denominator derivative of numerator and numerator derivative of the denominator by the denominator square, that is x minus 1 whole square. So x minus 1, we know derivative of x is 1, derivative of 1 is 0, so that is 1 into x minus 1 remains x minus 1, then x plus 1, and derivative of again x is 1 and minus 1 is 0, so that's why derivative of 1 is 0, so that's why again here we will get into 1. So that means x plus 1 into 1 is 1, nothing but okay. Now keep it x minus 1 whole square, x minus 1 minus, it is gonna be minus x minus 1, x minus 1 whole square. So here you can see minus x plus x cancel, minus 1 minus 1, that's minus 2, minus 2 by x minus 1 whole square. So this is our result. So now let me show you the number 7. So how to solve this? Now number 7, here the function is f of x is equal to 1 by ax square plus bx plus c. Now derivative of this function f dash x is equal to derivative of 1 by ax square plus bx plus c. Now considering this one as 1 by x, then we know derivative of 1 by x is minus 1 by x square. So according to that, it must be equal to minus 1 by ax square plus bx plus c whole square. But as you know, this is not x, this is not 1 by x, so that's why you have to differentiate this denominator again. So derivative of into derivative of ax square, sorry, I have written ax square plus bx plus c. Now you see derivative of ax square. So it can be written as a into derivative of x square. Derivative of x square we know twice x. So a into twice x means twice ax. You can write twice ax. Then derivative of bx. Derivative of bx means b into derivative of x, and derivative of x is 1, so b into 1 is nothing but b. And derivative of constant c is 0. That's why we will get 2ax plus b here. So 2ax plus b by ax square plus bx plus c whole square. So this is our result. So that's how we can find the derivative of question number 7, derivative of the function in the question number 7. So this is our answer. So number 8, here the function f of x is equal to ax plus b by px square plus qx plus r. So here also we are going to apply this u by v, derivative of u by v, that is quotient rule. That is derivative v derivative of u minus u derivative of v by v square. So f dash x is equal to denominator, that is px square plus qx plus r, derivative of the numerator, and numerator minus numerator is ax plus b, derivative of the denominator, which is px square plus qx plus r by the denominator square, px square plus qx plus r whole square. Now if you differentiate ax, then you will get a into 1, that is a, and if you differentiate b, then you will get 0. So here we got px square plus qx plus r into a, and if you differentiate px square, then you will get twice px, and if you differentiate qx, then you will get q, and if you differentiate r, you will get 0. So that's why here we have got minus ax plus b 2px plus q. Here it is px square plus qx plus r whole square. So now let's simplify the numerator part. So here we will get a px square plus a qx plus a r minus, so then we will get 2p ax square, then we will get minus q ax, just multiplication, simple multiplication. If you multiply these two, if you multiply this one and this one, then what you will get, that's what I am writing here, minus bq, sorry, I have left one term, b 2bpx, then minus bq by px square plus qx plus r whole square. So let me scroll up the page. Now check what other terms can be cancelled. So here you see qax and aqx, both are same terms. One is negative, another is positive, so they cancel each other. Then what we will get, so now pax square, apx square, same term. Here it is 2pax square, this is 1pax square, so we will get minus pax square only. So minus pax square. Then write the remaining parts. I don't think there is something more to simplify. Minus 2 pbx, then minus plus ar minus bq. That's all I think. Yes, by px square plus qx plus r whole square. So that's how you can solve question number 8. So this is the result. So here the function is f of x is equal to px square plus qx plus r by ax plus b. Again we are going to apply the quotient rule u by v. This one, sorry, here it should be derivative. Denominator derivative of the numerator minus numerator derivative of the denominator by denominator square. So considering the numerator as u, denominator as v, then f dash x, we will get ax plus b, derivative of px square, that is numerator px square plus qx plus r, minus the numerator px square plus qx plus r, derivative of the denominator, divided by the denominator square ax plus b whole square. Now ax plus b, derivative of px square is 2px, and derivative of qx will be q into 1, that is q only. This is qx, so it will be q, and derivative of r is constant, so it's gonna be 0 minus px square plus qx plus r. Then derivative of ax, simply a into 1, that is a, and derivative of b is 0. Derivative of b is 0. Okay, so now it is ax plus b whole square, denominator square. Now let us simplify the numerator again. Multiply these two, twice p(ax) square plus aqx twice bpx plus bq minus apx square plus aqx plus ar. So here you see, as it is negative, so this positive signs turns out to be negative. Okay, ax plus b whole square. Now what you can do here, these two terms gone, then you can subtract this one from here. Doing so, what we will get, let me scroll up the page. We will get a p x square, then sorry, yes, twice b p x plus bq minus ar by ax plus b whole square. So this is our result. So hope you have understood this. Now 10, f of x is equal to a by x to the power 4 minus b by x square plus cos x. This is the given function. So before we're gonna solve this, let me tell you one thing. Remember this one, it will help you to solve this. Derivative of x to the power n, 1 by x to the power n, actually 1 by x to the power n, which can be regarded as derivative of x to the power minus n. So that's gonna be minus n into x to the power minus n minus 1. So simply you can write minus n by x to the power n plus 1. So remember this one as derivative of 1 by x to the power n as minus n by x to the power n plus 1. So we're going to use this directly here. In this case, suppose if in case you have a constant here, any constant, suppose you have here constant c, then it will be n c x to the power n plus 1. So hope you have understood this. Now we're going to apply this. So derivative of this given function f dash x, so derivative of a by x to the power 4 minus b by x square plus cos x. Now you see a, b are constant. So here we're going to use this result, derivative of c by x to the power n. Okay, and using that we will get minus a 4, or you can write 4a by x to the power n plus 1. Here it is 4 plus 1, that is 5, and here it will be minus 2b by x cube, and derivative of cos x is minus sin x. So here it will be minus sin x. So that's equal to minus 4a by x to the power 5. Here it is minus, this is also minus, so it's going to be plus twice b by x cube minus sin x. So this is our result. That's how we can solve. And remaining problems from question number 11 to question number 30 we will solve in the next video, because it's thank you for watching, and if you like my videos, please share my videos with your friends, and if you think it is helpful for you, if you are new to my channel, subscribe the channel and give the thumbs up.